Good morning. This is Dr. Polaiah, working as a professor in IT, Institute of Aeronautical Engineering, Hyderabad. Today video that is on pseudo color image processing. The pseudo color image processing is a topic under the one of the module number 5, which is the syllabus which we are following or prescribed textbook based syllabus. So this pseudo color image processing is the topic which we are going to be discussing elaborately for the sake of understanding in terms of continuation of the previous topic. Next, so let me to introduce the pseudo color image processing. Pseudo color image processing. So what you wanted to understand here, pseudo color image processing is a technique that maps each of the gray levels of a black and white image into an assigned color. Black and white into assigned color. What is our color? In terms of RGB. In terms of RGB color. Okay. In terms of RGB color. So this color image when displayed can make the identification of certain features easier for the observer. So the mapping are computationally simple and fast. So what we understand from the pseudo color image processing is a method which is an approach for converting black and white image into your required color image. Okay, so such a image when we are mapping are computationally very simple and very fast also. But how we can do that? How can we proceed such an approach with the help of two majors? With the help of two major areas. What are those two major areas in this sense? Number one, full color processing. Number two, pseudo color processing. So full color processing, that are images are acquired with a full color sensor, color TV camera or color scanner, color camera, means you are going to be use such a acquiring images by the help of your selected sensor. The sensor nothing but a camera or a TV camera or a scanner, okay, or a digital camera. Okay, so color sensor based, you are going to be proceed. The first one is full color processing. Okay, whereas second one is pseudo color processing. That was just we understood from the previous classes and as well as just now from the previous slides also. So what we want to understand from here, so pseudo color images are generated by assigning a shape or by assigning a shade of color to a monochrome intensity or range of intensities. Range of intensities. So what we want to understand here is pseudo color processing is now we are going to be processing based on your required or your assigned shade of color to monochrome intensity, or we can say range of intensities generated. Okay, so that is the second area as a major area under the today topic what we are discussing. Okay, so coming to in the continuation, pseudo color image processing approaches are assigning color monochrome images based on the properties of gray level content. What do you mean gray level content? Black and white. So the black and white content of the image based only you are going to apply your selected approach, which is we called as your what we call that one is pseudo color image processing approach. So that means this pseudo color image approaching is right now concentrated on monochrome images only. Monochrome images only. That is, the term monochrome is usually taken to mean the same as black and white or more likely gray level, but may also be used to refer to other combinations containing only tones of a single color such as green and white or green and red. Okay, so such a approaches we are going to be proceed in terms of three approaches. What are these three approaches? What are these three approaches? Are number one, intensity slicing and color coding. Okay, so number two, gray level to color transformations. Number three, filtering approaches. Obviously, filtering approaches will be there in the pre-processing. Obviously, that is what we understood from the previous classes also. But point is here, such a three color image processing approaches are basically we are going to be concentrated on number one, intensity slicing and coding, gray level to color transformation, and third one will be your filtering approaches. With the help of these three approaches, it's easy to proceed in terms of your applied pseudo color image processing towards to converting black and white image into your color image processing. Okay, so for example, the previous class continuation, which is you are going to be understand here color models. Okay, this color model, how you are going to be use your three color approaches. Okay, three approaches applied here. Three color approaches are here. For example, what the color image you are using? Color image you are using. Okay, so this color image, once you are using, in the sense you are using sensor. Or sensor is 100% color camera or color TV. Okay, color TV, television process, or you may also going to be use your whatever scanner color, 100% scanner, it will be also color. So by using this sensor based selection only, you may be converted. While you are converting, you are required vice versa from the black and white, This is black and white. This is grayscale. What is this? Grayscale. What is this? Grayscale image. What do you mean to understand black and white means? Black and white image is nothing but your grayscale image. Okay, so you are going to be use your sensor will be your color image, your color camera or color TV, scanner will be a color obviously. So based on that, you wanted to convert into. So, but previously the technology is not be this much a friendly user technology. Now we are using by such approach, such a color models approach in terms of your pseudo color image processing is right now converted your black and white image into color. So there we are going to be apply your kind of process according to the your required application process. You wanted to send an image in terms of what we call as key image. You can convert such a color image or color black and white to color to your key image in terms of application point. Understand? So that is very important is here. That is very important. Next, coming to the there are pseudo color image processing will be continue with the help of two major categories of color image processing, which are we are already earlier slide where it help us to understand in terms of pseudo color, that is false color image processing, and the second one is full color image processing. Full color image processing. So that means your true color versus false color we are going to be checked together. So what does it mean your true color? What does it mean your false color images? Okay. So what does it mean true color image processing? So your true color images are images with natural color rendition or nothing but a red apple appears red, a blue ocean appears blue, etc. It's difficult to achieve absolute true color in images, but being approximately closer to human perception is acceptable. Human perception point of view is acceptable. Why? Because we are using is true color approach. So in the true color, what it says, red color apple will be appears red, obviously. But original that red color, how it so it's a red color, nothing but we can you can understand according to the human perception is acceptable. Similarly, you see the ocean, basically it shows the blue color, so it appears obviously blue color only. Whereas second approach, that is a false color images, it is sacrifice the natural color rendition in order to facilitate the dictation of some objects. They are mainly used for the satellite and space images process. So you can understand that the major distinction is in between color image processing, that is in terms of true color images and false color images. So what we can find this major differences, that is the natural color which we are going to be understand here in order to facilitate the detection of the some objectives. For example, where you are going to be concentrate such a technology, in terms of satellite image processing and space image processing. So there we can apply this image processing, obviously. There you can apply this image, obviously. Next, coming to the here, for the sake of understanding such a pseudo color image processing in terms of how you are applying from grayscale to color, let us see here. The pseudo color images are originally grayscale, which are assigned colors based on the intensity values. Intensity of the pixel values, you based only you are going to be applied your grayscale to color image. Okay, so that means typically usage of these images is for thermography, where the only available is infrared radiations instead of lights. Another example is elevation mapping. So one is we can understand the thermographic example. The second one is you can understand here elevation map. So how you are going to be understand your image in terms of thermography image. You can check. So this type of applications, okay, this type of application where we can use, you can apply this type of application, okay, in terms of understanding the examples of pseudo color images. Example of pseudo color images. How you are going to be understand here. For example, NASA concentrate on satellite image processing towards to in terms of thermography image processing. So you can understand how these thermography images are various in terms of temperature values also, in terms of centigrade or Fahrenheit. In terms of centigrade, one axis, Fahrenheit, another axis. You can compare both together. Okay, so such a application we are going to be apply your selected approach. Selected approach. Understand? Next, coming to this pseudo color image processing, we are concentrating as one more type of pseudo color image processing, that is intensity slicing. Intensity slicing means when you are going to be apply your images in terms of you are going to be applied in terms of slides. Slicing is like this. So one to other we can compare. This is called slicing. This is called slicing. This is a simple case of pseudo color image processing. It is also density slicing or color code. It is also called density slicing or color coding. So image, whatever your image processing is, right now you can understand that imagine it is grayscale images in terms of 3D functions with the intensity being the third dimension, that is 3D processing, 3D image processing. Placing a plane parallel to the horizontal plane for the pixel position coordinates would slice the images into two parts. After that, you can assign different colors to different levels. After that, we can assign different colors to different levels. So, such a processing, we can apply your pseudo color image. Understand? So, that is very important here. So, coming to such a thing, how can your understanding in terms of 3D image processing by the applying of intensity slicing is here. You can see y-axis and x-axis values are varies. How this f of x comma y is right now vary in terms of your x and y, but variation in 3D. Variation in 3D. How you can check it? Black and white processes. Let us assume black is nothing but 0, white is nothing but 1 in terms of digital. Okay, so this is the origin value 0. Okay, and from there you can understand you are going to be part of slicing plane. This is the plane. Okay, this is the plane. This plane right now you are going to be keeping into the slicing plane. Understand? You selected a slicing plane for your objective function of the image processing. Here where we can apply your obviously in terms of geometric interpretation of the intensity slicing technique. We are applying here geometric interpretation of the intensity slicing technique. Understand? So that we are going to be understand it is varies in terms of intensity axis values. Okay, intensity axis values is adjustable. So one to other slice how it may be changes is adjustable. So this part is you are going to be finding. Okay, so that is very important what we were concentrating in terms of intensity slicing based on the values which you are assigning from 0 to your required process of slicing. You are selecting, while you are converting grayscale to color, you are going to be select according to your requirement in terms of application achievement, in terms of your target application achievement. So, for example, let you can see in the continuation of your pseudo color image processing, here you are not constrained to use only one plane, but your multiple slices result in more flexible representation of your grayscale images, more flexible of the image processing. So in this case, the grayscale is parted into intervals and each one is assigned a different color. Each one is assigned a different color. For example, you can see the density sliding into 8 colors. So how you are converting this? Vice versa. So in this case, the grayscale is parted into intervals and each one is assigned a different color. Understand? So that is very important here. Okay. So next continuation, the intensity to color transformation, which we are concentrating here, we can generate in terms of generalize the above technique by performing the 3 independent transformations on the intensity of the image, resulting in 3 images which are the red, green, blue. That is RGB component images used to produce a color image. So that is your grayscale to your color. color image. How you are going to be produce? How you are going to be produced? How you are going to be produced? Understand? So that is transformation on the intensity of the image resulting in three images, which are the red, green, blue component based images to produce your required color. So let us see that how your pseudo color image processing is concentrating right now based on your selected image processing. Nothing but you are already aware about this, how your f of x comma y is varies in terms of your Cartesian coordinates of x and y of intensity. Slicing is various. Slicing is various. Understand? So red transformation, green transformation, blue transformation. Obviously, your f of x comma y 100% RGB color image. That what this diagram says. That's what this diagram says. This figure is obviously functional block diagram for pseudo image processing. Okay, so that means you are going to be achieve your objective function is convert in terms of red transformation. F of x comma y is transformed through red transformation. We called as f red f of x comma y. So that means your image completely in terms of red transform, red color. So similarly, you are going to be change here green x comma y. That is, you are going to be concentrated on green color. Green. So this is blue color. That is f of blue x comma y. So you are concentrated here. The image is here. You are going to be obviously is green, blue color. So this is blue color. So that is what we are going to understand from this. Okay. So coming to the in continuation, how your parts of the objective functions are varies from x of comma y is more flexible, can be even more enhanced by using more than one monochrome images. That is, best examples are three components of an RGB and the thermal image processing. So we discussed the both, that is components of RGB and the thermal image. So what we are going to be understand from this f of x comma y is transformation in terms of your required. It's not fixed, it is changes. Okay, so your transformed image, that is F2G. That is grayscale image processing to your required color image processing by using which approach? Pseudo color image processing approach. That is, we are processing here by the help of additional processing in terms of your required achievements. So this is red color, this is in terms of green color, this is blue color. But it is you want to change a number, it is not fixed. You can change this number of images according to your application processor. So this technique is right now. We are concentrating by the use of multispectral image processing. That is, so this multiplexing is not fixed from what we called T2. That is transformation. Transformation is TK, where K is varies from 0 to your n values. Okay, so that is very important here. So what we want to understand here, let me to summarize summary of color image processing is here. You are applied your pseudo color pseudo color image processing, pseudo color image processing is right now going to be used in terms of simply you are converting from grayscale image, grayscale image into your color image. What we are discuss this color image is nothing but it is nothing but color models. Color model. What do you mean models? So this color model means it's not fixed. The transformation of the image is not the fixed. Okay. So that is for example the previous class where we discussed suppose CMY color model. What do you mean this CMY color model? This is obviously depends upon RGB color. You are prepared. You are prepared. Your RGB color based. You are prepared. Your required CMY color. What does it mean CMY color model and all? We are discussed in the previous classes. Understand? So that is very important here. So coming to the why we are concentrating this pseudo color image processing is the approach, is the one of the approach which help us towards to develop your required develop the required application, develop the required application. Required application in the sense which we are discussing is here, is based on your application selected. That is in the previous where we are concentrated about this color image processing, where we can apply your complete image processing depends upon your required application. What are the application? Shall we revise that list of application in terms of multiple techniques based applications. What are those? Number one, in terms of interdisciplinary image processing. Number two, you are going to be understand not only interdisciplinary but multidisciplinary approach also. So that means image processing can be concentrated, medical image processing, survival. That means for the sake of surveillance, we are going to use this image processing. For the sake of you are going to be use your color image processing for the sake of artistic effects, for the sake of law enforcement, for the sake of okay. So why not? What not application can be implemented by the help of image processing today? So that is you are all concentrating such image processing in terms of color image processing is most and very important even in our day-to-day life where we are troubles to understand certain kind of difficulties. We can convert it in easy manner. We can transform it in easy manner by the help of today class. That is what we are understanding. Pseudo color image processing. Pseudo color image processing. I hope you enjoyed. I hope you understood the complete technique, which is pseudo color image processing for the sake of converting of your color gray, black and white to color for the sake of your achievement of your objective of the required applications. Understand? So that is very important. Is here. So I am stopping here our discussing by the referring in terms of your understanding from much more information from referred textbooks. These are the list of referred textbooks. You can also go through this. What are your confused in anywhere while the understanding about this video, you can also refer these two textbooks, and you can also go ahead with the help of certain another or some more video lectures also. Okay, I'm very thankful for your concentration on understanding of this today class on pseudo color image class. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.